How's it going, everyone? Eulier again. Today we're going to take a more practical approach on the React performance. By actually is look, take a look at this repo, which is taught by Steve Kinney, the head frontend engineer at Temporal, and now the instructor of this course. And the idea here is to see how now can we detect a particularly performing issue, even though that in their slides it mentioned what it is, but the question is that why it repeatedly slowing down rendering. Okay, as a way to investigate, detect this particularly rendering performance. So that's what we're gonna do today. Let's get into this. First, let me actually clone this repo here, and then React performance. Okay, git clone of this repo. Right now you're not able to see what I'm doing, but you will. And this is it. That's right. Let's open up now here this. Has to be by puzzling. Anyway, open recent, and I want to open a folder here. In this case is from the React performance Warman. There we got it. Yes, let's save this. All right, and all right, here we are. Here we are. Okay, you're gonna open up this. Analyzes a project folder structure here. It is using as the create react, if I am right. It is using as the create react. I think it is React script. Yes, it is. So let's going to now install is a dependency followed by the run or start command. Okay, so right now we can see is that it has several components: the application, color swatch, explaining the component, game input, and game status. And once we launch this, for example, so when we launch this to the browser, then we say, hey, enter some letters, right? It's actually, I'm expensive. It's interesting. Let's say BBF 33C. Okay, enter some letter and take a guess. Nope, sorry. Reset color. Enter some letters. Say FF0033. Okay, take a guess. Nope, sorry. Reset color. Oh, as a way to guess that color. Okay, as a way to. Okay. Okay. So, but this is in hexadecimal. Okay. CC 20. Say take a guess. Nope, sorry. Reset the color. And then you got it. The thing here is that once we try to inspect this, looking at the performance, specifically the profiler here. Okay, so far is the input is not that slow. Okay, so if we now start a profiling, a good metric for that color swatch and application. Exactly, it's actually rendering that quite fast. We clean up here. One millisecond of 2 milliseconds. So is that, exactly, it's not that slow. Oh, it's because we need to choose is a particularly initial slow down exercise. Oh, okay. That makes a lot of sense. Okay. Okay. So we say, hey, git, what are the branches that we got here? And it's this initial slowdown exercise. Git status, or in this case, git switch to that particular branch. Okay. So now when we run this, the npm start, bam, we look at this, and now it say, hey, enter some. Oh, this is quite easy. We say, hey, I think this is 0 in all cases. Oh, the input is quite slow, as you can see here. Take a guess. Now I'm sorry to set the color, but as you can see here is now the input is quite slow. So it's something related to this input, right? So because of that, let's take a look at the code here. So on the application color swatch and expensive components gain input, first things first is identify as a way to identify any performance issue is that if your application is slowing down when you're entering user inputs, there is something wrong in there. So in this particular case, we would like to know is what is the component hierarchy. So start from there. Okay, it's the component hierarchy. There you got it. As we can see here is this. This is the component hierarchy. Application, color swatch, gain inputs, game status, and expensive components. So there is something wrong here with the get inputs. That actually is when we type something here is taking too much time. All right. So let's get into this. First, let's get into the gain input here. As a way to take a look at the code here, it's quite much better. Let me actually remove this. All right. Oh, and yeah, the game input. There we got it. So in this game input, it has set couple values, couple props, value, and on chain is when it set the a setter on chains, a setter on has guess, and disable. So if we take a look now at the game input, when we are typing in here, okay, so when we type it here, the max length is 6, the pattern is passing is a regex, which is great. It's like, hey, this must be from this to this. The placeholder and followed by the props that is receiving here. This is the label. Okay. So it has now this on submit, that is on submit where it's going to actually pass that, followed by the event. It emit that to here, has set has guessed true. In this case, it's a on submit. If on submit is passed, you're gonna pass this now whatever you got in the event, which is React form, right? And they say, hey, on submit, if you detect that particular event, you want it to actually set the has guessed to true. All right. And the other is on change. So on change is now setting in the color here. So that's right. So here is when these things get to quite, I'm questioning is this. Because as you can see here, we are passing is a function here. And most of the time in our state right now is this. As you can see here, we're passing is a function here to our state. And if we take a look now at our state, okay, so for example, like this, use state, and if we take a look now at this TypeScript, this is not a TypeScript core, but it doesn't matter. The whole point of this is to analyze what are the proper argument that we can pass to. But as you can see here, what it's saying is that this can be is either the type of what we're passing. Remember, after all, genetics are factory of types that exist only at static level, and it is parameter representing is a type followed by and it is defined by it is angle bracket. So the thing here is that we are passing here now is we are running that function, we are calling that function like this, because we are calling this function and then we're gonna pass is the data. What is the generate random number here? And that's what it is. So here is actually blocking this. It's a function block from the sleep, okay, which is some utility function. That's a way to say, hey, I'm going to block the main thread here, okay. I'm gonna block the main thread here by measuring is the performance, not doing anything with that. Just simulating a synchronous function that is taking a lot of time. In here, we are evaluating is this on every render. So use state in React. This is one of the finicky aspects of the use states. Adding state to a component, updating state based on previous state, updating object on an array in state, avoiding recreating the initial state, Exactly, which is this particular case. Reacts. Let me actually make it visible there. Avoiding recreating the initial state like this. Avoiding recreating the initial state. React save the initial state once and ignore it on the next render. React save the initial state once and ignore it on the next render. Although the result of the create initial to-dos is only used for the initial render, you're still calling these functions on every render, and this can be wasteful if it is creating large array or performing expensive calculation. To solve this, you may pass it as initializer functions to the use state instead. So you pass is the reference and let now the React recreate that, which is you're gonna do that once and ignore it on next rendering. So as you can see now, this particular input is quite slow. All right. And in fact, let me actually is measuring is this by taking a look at the profiler here. Okay, and say take a guess, reset color, so something like this. Say hey, okay. As you can see here, the application now is taking 300 milliseconds. Similar for the immediate. And one of the great things of this is now it's showing us is select next commit. What caused this update? Application. Interesting. Okay. Flame chart. So the profiler here is now giving you all this basic information that you need. Again, this is very narrow specific to that, and it's giving you all of this information here. Rendering at for that. The other is to measuring now is using the performance here, for example, and you say start recording COFF33, take a guess, reset the color, cancel recording. Okay. 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 Well, actually, we are using is yeah, we're using is then we cancel recording. For some reason, we're not able to see this. No profile has been unloaded. Well, any case, let's go to Chrome. Let's go to Chrome. When we inspect this by looking at the show it completely. By looking is now In this case, I want you to follow me along to Chrome or Google, exactly, like so. There you got it. And here, we're using the profiler. You just want to check how these things work. Alright, and then stop it. See that actually we got a performance issue of 300 milliseconds. So according to also Google, is that in the case of performance is something around 300 per 300 milliseconds that the user is starting to notice there is some lag. And when we use now performance here, set the color. Let me actually reset this. Take again. Okay, take a guess. Stop it. As you can see here, is now indicating here that there is some huge load here. Scripting. So if you take a look now again, that now the full range, as you can see now, it's saying that hey, something is taking too much time here. Follow as this. So it's taking a lot of time is on the scripting. Okay, that's interesting. That's powerful. Yep, that's interesting. That's powerful. Interesting. So now this is actually measuring is that. Yep. Okay. And now in the performance, it's telling you what is measuring, and followed by this. It's taking now too much time for an interaction to take. Task itself take too much. That's long time. Long task here. And long task and long task. So the whole point of this is to analyze and see and to get yourself familiar as you expose to all of this kind of different metrics that is using now behind the scenes. Again, this is very narrow specific, so you can also get yourself familiar with that. And yeah, this is pretty much this. Yeah, this is pretty much this. So because there is something called avoid recreating the initial state, that makes a lot of sense here, and this will become our new Bible like this. So avoiding recreating the initial state is that because React saved the initial state once and ignored it on next re-render. But because we are now every time render, so because anytime we are updating its state, therefore we are now re-rendering these components. React here, what it's doing is to update. Okay, React here is doing is now update that. I mean, it's React is calling that function. It takes too much time, but ignore that. It's like, hey, yeah, I know that you did that. Good, and that's it, and that's it. You know, oh my God, it's like someone that give you a gift, all right, and then he putting up into another room. Oh, thanks. Pretty much that. Okay. So as a way to prevent this, because it is only used on the initial rendering, you're still calling these functions on every render. This can be a wasteful if it is creating large array of or performing expensive calculations. You solve this, you may pass it an initializer function to use a state instead. So this is one way you can solve it. The difference between passing an initializer and passing the initial state directly. So here we are passing now is the reference. Okay, exactly. Passing is a reference. This example passes the initializer function, so they create initials to do functions only run during initialization. It does not run when the component re-renders, such as when you type into the input. Okay, passing the initial state directly. Resetting the state with a key. So because avoid recreating the initial object here, one way to solve this issue is by passing is only this reference, where now React will evaluate that initialization once and no longer. So if we now, for example, do this, again this is plain old JavaScript, and if we, for example, take the profiler here, we take a new sample and we say, hey, now the input actually is work as expected. There is no delay. Okay, actually those delay decrease vastly, but vastly, because now there are milliseconds, commit at 4 seconds, render duration. But as you can see, is all of this. So now of course is actually reduce that. This is one way to actually prevent to recalculating or passing these initialization functions. So don't pass initialization functions. Pass is referencing this, so don't call that. All right. Okay. And luckily for us that this doc exists, because now we were able to understand what's going on with our use states. Interesting. Updating state based on previous state, or the updater function. All right. Okay. Yeah, it's telling you what it's doing. So, okay, this is a very specific use case of that. Okay, all right. Very narrow specific use case, which is something that you might encounter in your daily life. Find performance issue here. So, for example, here it's like find a performance issue. It's like find a performance issue. And then performing issue QA. Find a performance issue. Okay. Interesting. Find that. And the other is discussion about that. The performance issue. What? No, I wouldn't use effect. I mean, you might not need an effect when you need to update an state that depend on another state. No. So I'll calculate that during rendering. This is another alternative like that for catching expensive computation. Mm-hmm. So it is called. So the whole point of this is that is you can do that, or passing is just as a reference for that. So similar when you pass is now a function. It's like, hey, call these functions when you need it. Pretty much like that. Call this function when you need it, which is initially at the initial render, and then I don't need that. If every keystroke, well, my guess is that if every keystroke is actually triggering is a cascade effect, it's because that state is too high. Exactly, it's because that state is too high in the render tree, which means that weekend is actually lower than. Weekend actually is lower than. It's triggering a re-rendering of all of this. Exactly, they get new props. Okay. Probably just function, so they're gonna call eventually. Exactly. There's something here filtering items here. So do you need to actually filter this every time here? With first thing saw is this is a type of input field, especially in Correct. Because that state is actually being there. And when you now updating the state in that component, it will trigger now a cascade effect, which means that React will call the component that triggered that state update. It will compute the components, and then the output of that, which is a ESX, if that contains more React components, it will continually call that in a recursive way until there is no more. So, as a way to prevent this behavior, okay, we can use identify as this new item, set new item name, and only pass down data to those components that actually need that name or new item name or that particular state. So hey, this state should live here, okay? Exactly. Mm-hmm. So the thing here is that new items, uh, we can move now that state to that component. And also, this is named as the uncontrol control component, which it doesn't have any local states, and it is states are driven by its props. Exactly. So the whole point of this is that hey, keep it your information to yourself. Exactly. It's like taking your worst friends and not letting them hang out with the ones you like. Mm-hmm. wrapping the original items into an anonymous function. Okay. Yep. Mm-hmm. Yep. Yep. So reducing re-renderings. Now this is the reducing re-renderings. Okay. Reducing re-rendering. Actually, I'm quite familiar with this. Re-renderings. Why I'm quite familiar? Well, because I know how that React works behind the scenes, and I dedicate like 2 months to actually understand all of the finicky aspect and the little mechanism and how all of this fits together. So now it makes ton of sense to say, hey, yeah, this is what you gotta do. This is what you gotta do. This is what you gotta do. You know this machine, how that works, pretty much like a motorcycle. And then you say, all right, I know how this baby work. All right. Mm-hmm. I know how this baby work. All right. So reducing, re-rendering here. I'm not sure that you can see this. There you got it. So reducing re-renderings here by pushing down the state then. Reducing re-renders. Okay. This is now based on what is the example here? Wait, what? Okay, let me take a look at the resource. To-do list, wordman, packing list here. Okay. Packaging list. The whole point of this is to now pushing down in the state. Pulling content up with children's and pulling content up extra exercise and use memo and use callbacks and use reducer and dispatch. But again, this is when you want us to use now the context API. You know, it's pretty much like this. When they say pushing state down exercise. So pushing so tip 1 pushing or push stay down the tree or push stay down stay down to the proper component, because at the end of the day, when you choose that state will live, which what is the components owns that state, it will affect how now you're going to re-render, or it's going to affect now how all of these components in the subtree we're going to re-render them. Because after all, when the React now state update this rendering, when you update your state, you're gonna pass through this rendering mechanism, the trigger. The rendering is when you say, hey, when this state update happened, it wasn't these components. All right, now I'm gonna make this. I'm gonna calculate everything inside of that, prop states, any other values. And then the output, if that contains more React components, and I'm going to continuously call it until there is no more. This is something now, for example, with React Fiber, which I'm not sure that they actually still using is the VDOM. They're using something called virtual stack frames as any re-implementation of the React core algorithms. to now utilize and manage manually or whenever they need is the call stack, but for React components, for UI elements, not for functions. So this virtual stack frame is a very interesting concept. That now they are pushing that, and it provides some benefits because now they have the ability to decide when this component needs to render, rendering prioritizations, concurrent renderings, and they can now store all of that information in memory and decide whenever they see fit to call that component, to render that component. Unlike with the previous model, when they have this now tree render to actually do that, and they're using this call stack as a way to keep track where they are in the code. Or in other words, call stack is used in computers as a way to keep track the execution, as a way to keep track of the program execution. It's like, hey, where I am, you know. Pretty much, if you play any games like Battlefields, Dota, you name it, you want to know where you are in the map. And that's exactly pretty much what this call stack function is give you where you are currently at. So that's quite interesting. This is quite interesting. And with that, that'll be all for this video. Take care. Bye bye.